Hello everyone, I am Khaled Mahmood. Today I will give basic concepts on multivibrator and how to generate triangular wave using this multivibrator concept. So what is multivibrator? Multivibrator is an electronic circuit and we can generate non-sinusoidal oscillation with it and implement two-state systems like oscillators, timers, flip-flops. When I say two-state, I means digital high and digital low. There are three kind of multivibrator. One is astable and second one is monostable and the last one is bistable multivibrator. So what are they? First one is astable multivibrator. In case of astable multivibrator, there will be two states and both will be unstable and there will not be any triggering input. So output will oscillates between two unstable states. So second one is monostable multivibrator. Here one state will be unstable, in this case lower voltage, and one state will be stable and there will be a triggering input. Until triggering input is applied, the output will be in unstable state. When triggering is applied, output will be in the stable state for a definite time and then it will again move to the unstable state. Last one is bistable multivibrator. Here both states are stable and there will be two triggering input. So initially there will be a stable state and when triggering T1 is applied, the output will move to the second stable state, and until triggering T2 is applied, output will be on that stable state, and again when T2 is applied, then output again move to the previous stable state. Now we'll see how to implement a stable multivibrator, and for that first we'll see about the Smith trigger circuit. So this is the Smith trigger circuit and we have given a positive feedback and a inverting input. Let's see how it works. So this is a input. Now what will be the output here? From the input side we can see that we have given two threshold value. First one is lower threshold value and second one is higher threshold value or upper threshold value. Since we have given a inverting input, suppose initial output will be high for the low input. So our output will be high until when? Until the input cross the upper threshold value. So output will be higher. So when input cross the upper threshold value, output will become low. Up to when? Up to input cross the lower threshold value. When input cross the lower threshold value, output will be again high. And up to when? Up to again input cross the upper threshold value. So that's how the Smith trigger works. So what will be the transfer characteristic of the Smith trigger circuit? So this will be the V in, this will be the V out. Okay. From that input output characteristic, we have seen that the output will be high. Okay, say okay, high. Until when? Until our input cross the upper threshold value. So when input is upper threshold value, then output will be low. So up to when? Up to the our input is cross the our input cross the lower threshold value. So then output will be again high. So this voltage is the upper threshold voltage and this is the lower threshold voltage, and this is the transfer characteristic of our Smith trigger circuit. Now go back to the circuit. Okay. So since we have given a positive feedback, output will continuously grow and it will grow until the voltage is positive V set or negative V set. So the saturated voltage will be the voltage we are giving for the biasing. Suppose it is minus V set and it is positive V set. So since this is a positive feedback, there will be a portion of the voltage that will come back to the non-inverting terminal of the op amp. So what will be that voltage? The voltage will be R2 by plus R2 into output. So output can be plus V set or minus V set, and we can write it like vita. Suppose our output is V set. Okay, so this term is our vita. Okay, so what will be the output of the op amp? In this case, the output will be op amp is open loop gain and difference between the positive terminal voltage minus negative terminal voltage. The positive terminal voltage is here and the negative terminal voltage is V in. You can see here. Okay, so now if input beta in less than our V plus, that voltage, then our output voltage will be beta into V set. Okay, not sorry not beta, only V set. But when input voltage is greater than our beta plus voltage, then our output voltage will be minus V set. So from this characteristic graph we can say that the upper threshold voltage is beta V set, that, and the lower threshold voltage is minus beta V set, and the high voltage will be positive V set and the low voltage will be negative, okay, sorry, negative V set. Now we'll see how we can implement a stable multivibrator using the Smith trigger circuit. So from the previous circuit, one change that we have made, that we have withdrawn the manual voltage source and we have given the resistance and capacitor here, and positive feedback remains and there will be a negative feedback too. So how this works? Okay, let's see. From the previous slide we have seen that there will be two threshold voltage, one is higher and one will be lower, and we know the value of both. In ideal situation both will be beta V set and minus beta V set. So output will be positive V set or minus V set. I have already told that the output voltage positive V set and minus V set comes from the supply voltage that we are providing to the op amp. Okay, now initially suppose the output V0 is positive V set. So what will happen? So our capacitor will get charged. So how? So this will be the path and no current will flow into that, since we are considering a ideal op amp. So when capacitor will get charged, the capacitor voltage will be increasing. But if it crosses the upper threshold value, then the our output voltage will come back to the minus V set. And then the capacitor will charge and discharge to the that value minus beta V set, to the lower threshold value, and when it crosses that value, then our output will be again positive V set. So again it will be that, and our capacitor will charge up to the upper threshold value. So that will be continued and we'll get a square wave like that, and the time period will be, let's say, 2RC ln minus beta by 1 plus beta, and here beta is the contribution of the output voltage from the to the our positive terminal, and it is, I have already said, R2 by R1 plus R2. Now finally we will see how to generate our triangular wave. Previously we have seen how to generate square wave from the Smith trigger concept, and then adding resistance and capacitance to that circuit. And then we'll use a op-amp for the integration. We know op-amp can be used as the integrator. I will not explain here because time is limited here. But if we give the output of the square wave generator to the input of the integrator op-amp, then we'll get our desired output. Here we can see that this is the our input to the integrator circuit, and we will get it from the our Astable multivibrator, and after integrating it we'll get our triangular wave. So that's it.